Imagine this. What happens if an asteroid hits Earth in 2024? A chilling thought, isn't it? So let's delve into this unnerving hypothetical scenario. Picture an asteroid, a colossal chunk of rock and metal, hurtling through the vast expanse of space. Now, these celestial marauders can range considerably in size. Some are as small as a pebble, while others can be as large as a small city. For this scenario, let's consider a sizable asteroid, say, about the size of a football stadium. And speed? Asteroids don't amble, they sprint. Speeds can reach up to 56,000 miles per hour. That's over 70 times the speed of sound. And when an object of such size meets such speed, the result can be quite devastating. Now, imagine this asteroid, this football stadium-sized chunk of rock and metal, hurtling at breakneck speed, is on a collision course with our home planet. The clock is ticking, and in 2024 it makes landfall. The impact, as you might guess, would be nothing less than cataclysmic. The energy released would be equivalent to billions of atomic bombs. The immediate vicinity would be obliterated in an instant, reduced to a smoldering crater miles wide. But that's not all. The shock waves from the impact would ripple across the globe, causing earthquakes and tsunamis far from the point of impact. Skyscrapers would crumble like sandcastles, and entire cities could be washed away. And then there's the dust. The collision would throw up an enormous cloud of dust and debris into the atmosphere, blotting out the sun for months, maybe even years. This impact winter would cause temperatures to plummet, crops to fail, and potentially lead to a mass extinction event, similar to the one that wiped out the dinosaurs. A lot depends on the size, speed, and composition of the asteroid, but one thing is clear: the impact would be catastrophic. So, what happens scientifically when an asteroid collides with our blue planet? Well, let's unravel this mystery together. First, we need to understand what we're dealing with. An asteroid, in essence, is a chunk of rock or metal, a relic from the early solar system. The size of these cosmic travelers can vary dramatically. Some are as small as pebbles, while others can be hundreds of kilometers in diameter. When an asteroid approaches Earth, it's moving incredibly fast, typically tens of kilometers per second. The energy it carries is colossal, akin to the most powerful nuclear weapons. And when it collides with Earth, all that energy needs to go somewhere, and fast. This energy release is the first major effect of an asteroid impact. In a split second, the kinetic energy of the asteroid is converted into an explosion of light, heat, and sound. This can vaporize the asteroid and a significant amount of the ground, creating a crater. The size of the crater depends on the size and speed of the asteroid, but it can be many times the size of the original object. But the story doesn't end there. The impact also sends shockwaves through the Earth, which can cause earthquakes and tsunamis if the impact is near a body of water. And then there's the ejecta, the matter blasted out of the crater. This can be thrown high into the atmosphere, where it can block out sunlight and cause a nuclear winter effect. This is where the global climate effects come into play. The dust and aerosols in the atmosphere can block sunlight, leading to a drop in temperature. This can affect plant life, and by extension the entire food chain. So, while the impact itself is destructive, the aftermath can be equally devastating. The effects of an asteroid impact extend far beyond the impact site. It's a global catastrophe. The Earth has weathered such events before, but it's a reminder of our vulnerability in the vast expanse of space. History has already given us a glimpse of what an asteroid impact can do. So let's take a trip down memory lane to about 65 million years ago, when a celestial object, known as the Chicxulub impactor, struck Earth with the force of billions of atomic bombs. This impactor, around 6 miles wide, came hurtling towards our planet and left a crater over 100 miles wide in what is now the Yucatan Peninsula in Mexico. The aftermath? A mass extinction event that wiped out around 75% of all species on Earth, including the dinosaurs. Imagine that, these colossal creatures who dominated Earth for over 160 million years were wiped out in what, in geological terms, was the blink of an eye. Now, let's fast forward to a more recent event, the Tunguska event of 1908. This incident involved a comparatively smaller asteroid, about 120 feet in diameter. It exploded over the remote Tunguska region in Siberia, with a force estimated to be about 1,000 times that of the atomic bomb dropped on Hiroshima. Despite its smaller size, the Tunguska asteroid flattened over 800 square miles of forest, and its shockwave was felt thousands of miles away. Thankfully, due to the remote location, there were no documented human casualties, but it served as a stark reminder of the destructive potential of asteroids. Both these events, the Chicxulub impact and the Tunguska event, have significantly shaped our understanding of asteroid impacts. They've shown us that size doesn't always matter when it comes to destruction, and that even relatively smaller asteroids can have catastrophic effects. The past has shown us the devastating potential of asteroid impacts. But could we survive one in 2024? That's the question we'll delve into next. So stick around as we explore the bleak aftermath of a hypothetical asteroid impact in our current era. In the aftermath of such an event, what would life on Earth look like? One might imagine a scene out of a science fiction movie, but the reality could be far more devastating. Picture this. An asteroid impacts our planet. The immense energy of the collision vaporizes the asteroid and a large portion of the Earth's surface, creating a crater many miles wide. Dust and debris are thrown high into the atmosphere, blocking out the sun. This is where the concept of a nuclear winter comes into play. The sunlight would be blocked out for months or even years. Without sunlight, photosynthesis would halt. Plants would die off, followed by the herbivores that rely on them, and then the carnivores that prey on those herbivores. The food chain as we know it would collapse. The oceans would not be spared either. The impact would cause massive tsunamis, wiping out coastal cities and marine life alike. The dust in the atmosphere would also cause a dramatic drop in temperatures, leading to a deep freeze across the globe. As for us humans, we would be facing a trio of calamities: the immediate devastation of the impact, the long-term effects of a nuclear winter, and the societal collapse that would likely follow. Infrastructure would crumble, resources would become scarce, and the societal norms we rely upon would disintegrate. Survivors would have to contend with a world that's vastly different from the one we know. We could expect mass migrations as people scrambled to find habitable zones. Societal structures would need to be rebuilt from the ground up, and the scarcity of resources could lead to conflict. In essence, we're talking about a mass extinction event, similar to the one that wiped out the dinosaurs 65 million years ago. The aftermath of such an event would be a world that's unrecognizable from the one we live in today. Life as we know it would change dramatically, possibly even cease to exist. Is there anything we can do to prevent such a disaster, one might ask? In this day and age where science fiction often becomes science fact, we've developed strategies to combat this celestial threat. Let's turn our attention to NASA's Planetary Defense Coordination Office. This group's mission is not straight out of a Hollywood blockbuster, but a very real and essential endeavor. They're our first line of defense, responsible for early detection of near-Earth objects, or NEOs, that could pose a risk to our planet. With a network of telescopes scanning the skies, they're our watchful guardians, identifying potentially hazardous asteroids years, even decades before any possible impact. But spotting these cosmic interlopers is only the first step. What can we do if we find a rogue asteroid on a collision course with Earth? Enter DART, the Double Asteroid Redirection Test. This mission, currently under development, is set to demonstrate a method of asteroid deflection known as a kinetic impactor. In simpler terms, DART plans to crash a spacecraft into an asteroid at high speed, nudging it off its path. It won't be a big change, but when done far enough in advance, even a small shift in trajectory can mean the difference between an asteroid hitting Earth or harmlessly passing by. Of course, these are early days, and much remains to be explored and understood. Space is vast and full of uncertainties. But the fact that we're taking steps, that we're not sitting idle, is a testament to human ingenuity and our will to survive. While the threat of an asteroid impact is real, so too are our efforts to prevent such a catastrophe. From detection to deflection, we're investing time, resources and brain power to ensure that if the worst-case scenario were to unfold, we wouldn't be caught unprepared. Today, we're not just dreaming of survival, we're actively working towards it.